This video is to share our WCV 2023 paper, Fine-Grained Affordance Annotation for Egocentric Hand-Object Interaction Videos. Affordance is a very important concept in hand-object interactions, which is the possibility of action between human and objects. Depends on both our motor capacity and the object's physical properties. Most existing affordance datasets use actions as affordance labels to represent the action possibility, confuse affordance with object functionality and goal-related action. For example, scrapable and cut are the motor capacities extended by tools, not owned by human nature, so they cannot be used as a affordance label. And turn off is a goal-related action that not suitable for affordance, because we can use the same affordance to achieve different goals. And these datasets also neglect the human motor capacity, which is an important component of affordance. To address these problems, we need to distinguish affordance from other concepts. We follow definitions in the three-action system model to separate hand-object interaction and object-object interaction. They define affordance as a hand-centered goal-irrelevant animal-relative object property. This definition limits affordance in the hand-object interface. They also define mechanical actions as tool-centered mechanical action possibilities between objects. This fills in the gap of action possibilities in object-object interaction. These definitions clearly distinguish affordance from other concepts. Followed by them, we propose an affordance annotation scheme for hand-object interaction videos. Given an action video dataset, we first divide action labels from the original dataset into non-two-use actions and two-use actions based on their meaning. Because two-use actions contain object-object interactions, we need to annotate the mechanical actions for them. As we can see in these examples, the action labels of two-use actions always denote the interaction between two objects, so we use the action labels as the mechanical action label. As for affordance label, we need a label that can represent object property and human motor capacity at the same time. As for object property, we use goal-irrelevant motor action labels like pull, push. This verbs denotes what the objects of force. For example, pull denotes the pullable property of the cabinet, and we use hand grasp tape to model human motor capacity. Here we use a 6-glass grasp tape taxonomy simplified from Fix's work. By combining goal-irrelevant motor action and hand grasp tape together, we got our affordance label. Different from mechanical action, we need to annotate the affordance for both non-two-use actions and two-use actions. To reduce the manual work, we propose an efficient affordance annotation scheme, based on the assumption that everyone tends to interacting with the same object in the same way. Inside the application dataset, each action is performed by multiple participants, and each participant contains multiple video clips. These video clips usually demonstrating the participant doing the same interaction. And here is the annotation scheme. With this annotation scheme, we annotate a 60-class affordance annotation for 18,000 video clips, and we evaluate our annotation on different tasks. Here are the visualization results of the affordance recognition model and mechanical action recognition model. You can find that the affordance model focuses more on the hand-object interaction, and the mechanical action model puts more attention on the interaction between objects. This demonstrates the clarity of our affordance annotation scheme and leads to affordance's better generalization ability on different domains. We also compare affordance labels with action labels on the interaction hotspots prediction test. The model trained with affordance labels outperforms in both accuracy and granularity. That's all for my presentation. Thank you.